Hello, Tomer.
Good morning, Paul.
Good afternoon to you. How are you doing?
Excellent, thank you.
Beautiful. How's your weather in Israel today?
Here in the air conditioning, it's quite nice. Outside, it's probably horrible.
Really?
It's really hot
What,
those
what,
last couple of
what,
days.
what's really hot? What do you describe as really hot?
It's something in the area of 35 to 38
Oh,
Celsius degrees and high levels of humidity, 70 plus.
whoa, very nice. Well, here in Toronto, we've had that kind of summer. We've had a very hot summer, but now we're seeing the seasonal shift coming, so we have some cooler days, but we're still in the mid to high 20s today, so it's quite beautiful. No complaints about that yet. I understand you guys are coming up to a period of quarantine again.
Yes, it should start on Friday for a period of 3 weeks or more. No, it's not really clear. Um, it's a holiday season, so it's not really affecting the regular business of the country, but we'll see if it will have an effect on the virus.
Well, hopefully so. I don't know in North America what's going to happen yet. South of the border, certainly they're seeing an increase, and we're now seeing an increase here now that the kids are back at school and all of that. So, yeah, just have to wait and see. It's the story around the world right now, I'm afraid. A question for you, though. Tell me something. So, I hear more and more and read more and more about PCI 4. Is PCI 4 real? Is it coming? Tell me a little bit about, and for those who are dialing in and listening, tell a little bit about PCI 4 and what's happening in that world.
Yeah, so PCI 4 was delayed for a very long period of time because there wasn't really any reason to push it, because the main users for PCI bus are storage devices and GPUs. GPUs doesn't really need more than the bandwidth of the PCI 3, which is in the area of 100 gigabits. And storage device doesn't get to those areas, not even near those areas, so it really wasn't an issue. But recently, some SSD devices starting to use PCI 4. And the reason is because with an SSD device, especially on laptops, you use a smaller bus. So you don't use the X16 bus, which is 16-bit, you use a 4-bit bus. And then you do need the higher frequency in order to get to a reasonable bandwidth. So this is why the industry started moving to the PCI 4. So it started from the laptops. Currently, on the server side, AMD is already supporting it. Intel is not supporting it yet. It should support it by the end of the year with the next release. And PCI 4 enables double the bandwidth of PCI 3. So it's 2 times the frequency, same bus wide. You do have PCI 3 with 32-bit bus wide on some servers, but it's kind of unique. It's not really a consumer product. And with PCI 4, you do have double bandwidth. Also, PCI 5 is also on the roadmap, which should double the bandwidth once again. But I think this is in the
Wow.
longer future.
Wow.
We didn't say why it's relevant to us in our conversation, mainly for the uncompressed video. In order to handle high amounts of uncompressed video over IP, you do need those high bandwidth interfaces. And this is one of the unique use cases for PCI 4.
Very cool. Well, hopefully we'll start to see things rolling out quickly. Certainly for us, it's a wonderful opportunity just to take the pressure off and open the lid on the software to see where we can go. But especially with uncompressed, that's super exciting. Hopefully we'll see its deployment start to roll out en masse and become the thing. I know it's been marinating for a little while now. So very cool, very interesting. So looking at the clock here, as he looks up at the clock, I think maybe it's time to get going. What do you think? You all set?
Yeah.
Okay. Let's do this. Director, cue the slide. Roll the elephant. I guess we don't have an elephant slide. Good morning. Oh, you can come back to me. That's fine. Good morning. I'm Paul, working with Tag Video Systems, and I'd like to welcome you to our webinar today. We're going to talk about the alphabet soup of formats. You know, we support all formats across all parts of the ecosystem pretty much, and it's occurred to us in our conversations with customers that there's not a hugely complete picture out there of all the formats in use, where they're used in the ecosystem, and so on. So we thought doing a little A to Z on that would be a useful thing. And I'm joined today by Tomer Schechter, our Chief Technology Officer and one of the smartest men I've met in my life. Hello, Tomer. Thank you for joining and doing this.
Thank you.
You've got better things to do, but now you're blushing. Yeah, I can actually almost tell. That's brilliant. Anyway, so if we can go to the slide, what we're going to talk about is the ecosystem in front of you here. And this is kind of, you know, a very simplistic drawing of our whole world in a way. We create content, either through content creators who do this in an offline manner or through live events. And then we send it to people to consume, either through broadcasting, the traditional method, which could be over the air, or through pay TV, cable TV, satellite, and so on, or through over the top. And across this ecosystem, we see a huge variety of formats and transports, and that's what we'd like to talk about today. On our next slide, I'll tell you just a little bit about TAG. We are a probing and monitoring and multi-viewing company, and everything we do is software. There's no hardware. In fact, in the cloud, there is only virtual hardware. We run 100% software. We are 100% IP, and we run on commercial off-the-shelf server hardware or in the cloud. We do uncompressed and compressed, and we serve the entire ecosystem, the 4 bullets you see on the slide. We probe well over 330 points. I don't even know what that number is anymore, but it's beyond that. We can do 4K in and out, and we have open APIs for entire control capability through network management systems, broadcast control systems, and element management systems. And right now, we're well above this 50,000 number. It's an old slide, I guess. Next slide, please. The solution is really quite simple. We provide visualization, probing, and monitoring. We offer very low latency of under 2 frames in uncompressed and compressed 4K out. We don't even have a hard drive in the server. It's a software image in a physical instance. It runs directly off the dongle. You plug in the USB. We can also run it as a virtual machine. Of course, we can run it in the cloud. We do AVR and TS monitoring in a single solution, so you can monitor your entire distribution system end to end. Do very high density monitoring. We do deep integration with NMS, EMS, and BCS vendors, allowing really deep and end-to-end path-based correlation. And everything is accessed through our API. We have a single API, and everything, the GUI, remote control, and everything is done through that API. So a very, very nicely compact, nicely integrated solution. Next one. So here's what we're going to talk about today, and here's our little roadmap. This is our ecosystem presented in a slightly different manner from end to end, from content acquisition and creation on the left to consumption on the right. And so we're going to work through these little steps, and Tomer is going to take us on a tour of the landscape. Next slide, if we could. Here's our first area of interest. When you have a TV plant, a facility, a production studio, this is the live production and the content creation end of the system. We acquire a lot of external feeds. These could be feeds for news, these could be remote interview feeds, these could be network feeds incoming as contribution to you, and so on. So let's look at this first domain and what goes on there. Tomer, tell us about what we find in the wildlife of this ecosystem.
Okay, so usually the sources will come as a high bandwidth compressed sources or uncompressed sources. If we're talking about high bandwidth sources, those are IAVC, J2K sources, where you have a low loss of quality. The reason for this is because it's before editing, not editing, but before adding overlays, logos, doing color correction, and so on. So you need the highest quality possible. So you'll have something to work with, the best quality that you can. This is why regular encoding is not good enough, because it's reduces the quality. So usually JPEG J2K will be the mezzanine format in order to receive the content. In some cases, it's IAVC, where it's 100 megabits streams, and in some cases, it can come over uncompressed feeds.
So both acquiring these and monitoring these are very important to a facility, because these may be contribution to the actual show production. They may also simply be news feeds, very common in a broadcasting organization to pull in feeds from many news organizations for distribution to the various production staff, and often for integration into the shows. Most broadcasters record competition news feeds and pool news feeds so they can use them. So these are really important points in a system, and these are points that are out of the operator's control. So it's really important to monitor and probe these points to be sure that you have a constant handle on that. If we can go to the drawing again, let's look at something a little more difficult. This is the challenging part of television on the next slide, and that's live production. Live production, the critical high bandwidth, high quality environment. It's live, it's real time. You can never lose it. Tomer, tell us about live production and the formats and the considerations there.
Okay, in live production, it's a completely different game, because it's all about latency. It's about combining different feeds from different locations, different cameras, taking the audio separately from the video, having a fast feedback to what's going on. And you also have important metrics of the video quality itself, color correction, color accuracy. Usually those things are not so important later on the path, because already somebody did all of this correction and tuning. But the live production part, those are very important parameters of the content.
Talk a little bit about how our transition from SDI has worked, because studios have traditionally used SDI. And there was a two-step process getting to our current live production technology of 2110. Talk a little bit for me, if you will, about the IP equivalent of SDI 2022-6 and why it might not be the right format for live production and where it might fit in a system.
Okay, so I have to go a step backwards. And in the past, we had the ASI. ASI was the way to move compressed content from point to point. It was the same cable as the SDI cable, a coax cable. You could push over it up to 270 megabits, which was more than enough for compressed content. And the transition was to IP to gigabit networks. So the bandwidth of the network was a lot higher than what used to be on the ASI. So the transition was kind of smooth. On the uncompressed, we're using SDI. Nobody, I think, uses regular SDI today. Everybody's using HD SDI or 12G SDI. With HD SDI, we're talking about 1.5 gigabits of content, gigabit per second, or 3 gigabit per second for 60 frames per second. And here the transition into a gigabit network is not possible anymore. So we had to do something else, and the transition was to 10 gig networks and 100 gig networks. Also on a 100 gig network, it's not so simple, because if you have 3 gig per feed, you can only push theoretically up to 30 feeds per cable. Where in the move from ASI to IP, you could push hundreds of channels on the network. So the network bandwidth wasn't a parameter in anything. Now, on the move from SDI to uncompressed over IP, the bandwidth is a very dramatic parameter. Now, the transition was done in two phases. The first phase was the move from SDI to 2022-6, ST 2022-6, where you're just taking the SDI as is and encapsulate it with IP headers and send it over the network. So this protocol doesn't split the audio and video from the original SDI. So you have the full flow as is, the original one. You can't touch parts of it, only the whole stream. And also, there's no clock and sync parameters, because you're just taking the SDI with a very simple depending, but a simple gateway which just converts it to IP, and on the other side converts it back from IP to SDI, and you can continue working with your regular SDI equipment, only have an IP network in the middle, either between different areas or even in the local production area. So this was the phase A, quite simple because you can utilize all of the old SDI equipment. The second phase is the move to...
Go ahead.
Yeah. So the second phase is the move to 2110-20. It's a combination of multiple standards, different standards for video, audio, metadata, and so on. The idea with the 2110 is to split the content into separate instances, meaning the video can be processed without touching the audio and vice versa. In this transition, the gateways are a bit more sophisticated, more complex, because you need to split the original SDI content, you need to recombine it, and also this opened the door to start using native IP devices, not just gateways between SDI and IP.
Absolutely. And anybody who's built large production studios, and I've got the scars of that, you know the very first thing you do when you receive an SDI is you send it to a huge bank of audio demuxes and you peel off the audio and send it off to the audio room. And to do that in IP with SDI would be ridiculous. We'd be sending a 1.5 gig of video on a 10 gig link into the audio room so you could peel off a few megabits of audio. So 2110, while increasing complexity, really opens the door to a huge amount of flexibility in live production. So back to our ecosystem then. After we do our production, whether it's played out, being pre-prepared, or whether it's live, we have to broadcast it. And on the next slide, we go through a phase of operation that all broadcasters go through, not so much the over-the-top broadcasters. But if that slide were to appear on the screen, you would see that we're going to talk about master control and playout. There we go. This is where we play out and we put together the on-air presentation, integration in broadcasting, the integration of commercials and bumpers and logos and all of that stuff with program and commercial content. So Tomer, this is an interesting domain because here is where we take live signals coming from the live environment, and we also take signals from a playout system, the soap operas and the daily shows that are episodic, they're pre-recorded. So we integrate all of that in master control. What kind of formats do we see going on in that domain?
So the most common one today is the 2022-6, of course, after SDI. With the 2022-6, there is the big advantage that everything is combined together. So in audio, video, sync loss, and those kind of issues are less probable to happen. I do believe that in the future, everything will migrate solely to 2110. Again, for the same reasons that we said earlier, equipment is evolving and you have more options. And once you do have more options and more belief in the technology, you can use the more advanced methods. Also, in some cases, we can see compressed content in this level, either J2K or IVC. Again, it depends on the type of content and the way that the infrastructure is built.
Okay, very good. And we have a mix of a bunch of stuff. We have players that are playing compressed files, and these files could readily be coming out in compressed and utilized in the compressed mode, but in fact we have to get everything into a common format for integration at the master control switcher. This is kind of specific, of course, to broadcasting, where we have a mix of live and episodic pre-recorded material. But moving downstream, let's move a little bit further towards consumption. And I'd like to look at consumption in a couple of ways. One is legacy consumption, and legacy consumption is what I'll call streaming, and it's a bad term. I'm wearing the technical hat here because it is putting out live, real-time, continuous streams, as opposed to over the top, where it's not quite the same. But it's not what many people call streaming, but it's akin to what we broadcast on satellite and what we broadcast over the transmitters on the air. I didn't want to talk about the over-the-air protocols particularly, but let's talk about IP protocols in use in the streaming, as I just defined it, domain.
So in this case, I think all of the streaming is going over transport stream. So usually from the encoders, you'll have a transport stream going either to a satellite MAX or a cable MAX, or even a transcoder for a OTT. The advantage of the transport stream is that it enables combining multiple programs together, multiple essences of different audio languages, different subtitles, closed captions. So you can send everything all together on the same transport. Currently, I don't think that there is any other alternative. There are some cases where RTMP is being used, but again, RTMP can't really be used in the same way. It's a point-to-point protocol. It doesn't allow all of this different metadata to be pushed along the content. But it is, in some OTT cases, the protocol that is being used to push the content forward.
What sort of compression formats are we encountering over these transports?
At this point, it will be today, I think, mostly H.264, in some cases HEVC. MPEG-2, of course, is obsolete and not used anymore. J2K, in this case, also will not be used. The bandwidth is too high. So mainly, you will see H.264. HEVC will be used less because of the higher latency that it requires and higher performance that it requires. Again, it's not related to quality because at this point you can use whatever bandwidth that you want.
Right. So just as a funny side note, is HEVC a necessity for internet delivery? I know HEVC was attempted to, squeeze down the video so we could use existing over-the-air bandwidths with 4K. But enough bits of MPEG-4 kind of does the same thing. Well, what's your feeling on that?
It's an excellent question. It's always a game between the complexity of the encoder, the available bandwidth, and the required resolutions that the customer wants. So when we had the MPEG-2, we wanted higher quality, lower bandwidth, and so on. So we moved to H.264, but once H.264 got to be used, the MPEG-2 was also improved and got to not equivalent, but also better quality. And then we had the HEVC, which pushed. But again, the downside was a performance requirement, meaning that on a mobile devices, it eats more of the battery. Not all the devices are supporting it, meaning that you need to create different variants of the feeds for different devices. Not all of the devices supporting the same feature set. So you have a higher level of complexity of the support needed. It uses more battery. Yes, the quality per bandwidth is better, but I think that today bandwidth, if you're talking about home users with a set-top box, OTT set-top box, bandwidth is not so much of an issue. So it depends how you look at the equation.
It's funny, too, because it fits a bigger technological picture, and we always have this leapfrogging effect where we develop a better compression standard to accommodate quality at a bandwidth point. And by the time we get there, the bandwidth is available to make that maybe less necessary, but then it opens the door to us getting more quality because we have more bandwidth. So it's fun to watch that evolution of codecs. I'll come back to that at the end. You talked about multiple renditions, and that leads me to the next topic. And that's, of course, really where distribution is moving today in a very big way, both for packaged content as well now for live content. That's over the top. Give us, Tomer, a very flowery description of the whole domain of over the top and how it works and the kinds of formats we encounter in there.
Okay, so it is very complex. The way to push content into an internet client, I'll call it an internet client because it sits on the other side of the internet, and the content needs to get to the customer over the internet. It's very important to say internet and not IP. And the reason is that over the internet, you can't have multicast streaming like you have in IPTV and like you have in the broadcast facility. You have only a regular file transfer protocols which work the best, and you have some streaming formats which might in the future catch up and be able to replace the current formats. But the current format is file-based. So if you're talking about HLS, MPEG-Dash, and Microsoft Smooth Streaming, those are the three main protocols today in order to push content to the customers. They're all based on sending files, chunks of content, and manifest files which describes how to reattach those video and audio files. The different implementations play with the size, the length of the chunks, with how to split the audio and the video, and the format. But in the end, it's the same idea of sending small files. The advantage with sending files is that it's a very simple protocol. You have it enables usage of CDN. A CDN is a nice word for caching servers. Those caching servers are just holding files on the internet and enabling a closer point to the customer in order to pull the content. So if I need to pull a content from a broadcaster in Canada, I don't need to pull it directly from Canada. I can pull it from the edge of the CDN in my region, where he already has the caching of those files because other customers already watch the same content, or in parallel. So this is the basic edge part of the delivery. So in this case, we have different customers watching the same content over different devices. And if somebody wants to supply to my endpoint the highest quality possible, and I have a 4K TV and a very advanced, let's say, Apple TV player, then the content will be sent as HEVC with Dolby Atmos sound, with 20 channels around and all of the features. But if somebody else wants to watch the same content over a mobile phone, of course, he can't support the same set of codecs, so he needs to get a different rendition of the content. The problem is more complex because the technology changes all the time, and everybody wants to push to the next protocol, next codec, and so on. And you still need to supply compliance to all the protocols and codecs. And then we find ourselves with multiple different renditions, both in order to support different bandwidth of the transport delivery, if it's over cellular or a dedicated line, and also different devices. So in the end, in some cases, vendors, broadcasters find themselves with 10 renditions, 20 renditions of the same content for different devices, different resolutions, different bandwidth. In order to create all of those renditions, you're using a transcoder, meaning the transcoder receives a single transport stream with the produced content, with everything in it, the audios, the subtitling, the metadata, everything, and creates different renditions in parallel, which are also in sync. Why you need those to be in sync? Because you have adaptive rate, ABR it's called, I think, adaptive bitrate conditions maybe, where the player can move between different rates on a live playback. So if you were using a mobile device and you have better reception or worse reception, it can move to a different bandwidth usage. And in order to have a seamless transition, everything needs to be in sync, meaning that each chunk of the content needs to start exactly on the same frame and have exactly the same audio and the same everything.
Well, and that's one of the strengths, of course, of the OTT mechanism, is that we can accommodate this dynamic resolution capability to accommodate different links, and you know that's absolutely necessary as the internet evolves. We don't have the pipe like we do in cable TV or we do in over-the-air broadcasting. We've not said, but it's worth mentioning, I guess, just in case it's not clear, that all of this lives in the cloud. OTT is a cloud thing; it's an internet thing. And the content is either living probably in the cloud for availability for broadcast over OTT, or a live stream is fed to the cloud And from there, it goes down the cloud distribution path or the legacy distribution path. But now that I've brought up cloud, I wanted to come back to the tough thing we started with, which was live production, Tomer, because one of the grails today is being able to do live production in the cloud, whether that means moving everything into the cloud or moving key pieces into the cloud. The COVID crisis has forced everyone to try and figure out how to get work done without actually being physically present or being able to build a team. So live in the cloud is becoming a big thing, but 10 gigabits from the ground to the cloud for a few SDI bandwidths is a tough problem. Getting all of that software to run in the cloud is a tough problem. Can you give us just some conversation and insight into the challenges of moving live production into the cloud and how that may evolve?
Well, it's I think that like everything, also the live production will move to the cloud. The question is only in what pace. The problems that we have today is mainly, I think, the bandwidth. Of course, the bandwidth is a problem for us today, but not in order to test the technology. If somebody wants to do a POC, you can have a 10 gig line to the cloud. You can push some feeds into the cloud and do the production. Of course, not from any region, not in any situation, but in general, it's already possible today. And we can expect that, in the future, this will be less and less of a problem. So planning ahead, yes, it is not really an issue, the bandwidth. The main difference is the latency, not so much as latency as we know it from video. It's the latency because the system which is doing the live production sits in a remote area. So you have a very, it's a basic latency like everything which is done in remote. But it doesn't mean that you'll have a higher latency for the broadcast itself, because the feed from the camera goes after some regular devices, like it's on-prem, in the same way it goes to the cloud, to the same devices, and in the end goes to the encoder and to the customer. So this flow is almost the same. The only change in the flow is for the production guys, where they need to edit the content, the live content, and are sitting not where the content is. So this is the small difference in latency. But I think that it's something that people can get used to, in the same way that we all used to working with mobile phones and not regular line phones, where you don't have real delay, and you do have it on cellular phones.
So there's two challenges with the cloud I'd just like you to comment on. And this is coming from a guy whose first modem was a 300 baud acoustic coupler, okay? But still, bandwidth is not enough. So to do live production in the cloud, getting from ground to cloud, cloud to ground, requires two things. It requires dealing with the bandwidth that's available, which is probably less than you need for many productions. So some kind of compression is still necessary. And as well, you need to protect that link. We need to somehow prevent data loss, which of course the internet or any kind of internet link is famous for. TCP takes care of that for us. We probably, for latency reasons, don't want to use TCP. How do we handle today's reduced bit rates, availability into the internet, and how do we protect the links?
Okay, so we have maybe 3.5 options how to encode the content in this case. The basic one will be IIVC. It's 100 megabit encoded iframe only encoded content. The next thing which makes more sense is J2K. We all know J2K. Usually we're talking about 100 to 200 megabits of content per HD feed. And the third option will be JPEG XS, which is hot from the oven. It's just starting. The advantage of JPEG XS compared to J2K is the native support for UHD and the ability to implement it better on software. When we're talking about cloud, we're talking about software. It's usually on the cloud, you have software implementation running on virtual images. And in order for this to make sense, you need a good implementation of the codecs. The J2K was designed for FPGA implementation, so it's not really natively running good on software. And JPEG XS was designed in order to run better on software implementation. I'm saying 2.5, 3.5 because also VC2 is also an option in some cases. It's kind of equivalent to the other options. So this is the encoding side. So we're talking about something between 100 to 200 megabits per second of content. Sending 100 to 200 megabits of content to the cloud, if we do it over TCP, it means that we have lots of higher delay because of the acknowledge protocol and so all of this behavior. And if you're just sending it by UDP, then of course some of the packets will not arrive to the other side and then will not be able to decode the content on the cloud. The way to solve it is a combination of forward error correction. Forward error correction is a way that you encode the content in parallel to additional information which enables you to rebuild missing parts of the content, just like a set of RAID hard drives. And the other thing is path control. So if you need to get the content from point A to point E, and in the way you need to go through point B, C, D on the internet, the ability to control the path of the content and to split it between different lines, different paths, will give you higher reliability of the connection. For this, we have multiple different options. We have Zixi, which is a brand which supplies such a protocol. We have SRT and RIST. Different implementations for the same global idea. I don't want to compare between those. It's a very difficult comparison. But in general, all of those solutions comes to solve the same problem of moving content from point A to point E. I'm intentionally not saying point B, because this is part of the solution, is to go through servers in the middle and supply better control and redundancy on the path. So the combination of one of those protocols along with a high quality encoding like JPEG XS supplies the ability to push a camera feed from the ground to the cloud.
And within the cloud as well, technologies like that will be, I think, very useful. And so, I guess like the leapfrog of compression and bandwidths, the same thing applies here. Bandwidths will continue to escalate, and we'll look back someday and see how silly it was to jump through all these hoops. But these are some necessary pieces in order to do that. One question, it seems that compression standards continue to evolve. Will it ever end? What's your opinion?
Well, it will never end because somebody needs to supply work for all of the engineers that have a doctorate in developing those algorithms. I think that the basic question is UHD enough? Why do we have 8K screens? Why do we need to send content in 8K and not to the cinemas? In the cinema, I can understand it. It's a really large screen. At home, I don't really see how it can be used, but everybody's talking about 8K. In order to send 8K, you need a better encoding format because the bandwidth is too high and so on. So it's an endless game.
Yeah, I agree. I think you're right. And because it's software world going forward, maybe someday an organic world, but certainly not hardware, we don't have to lock ourselves down to rigid standards like we did in the past, which served us so well. I mean, MPEG 2, my God, amazing. MPEG transport stream, MPEG coding, it's brilliant. But the ability to be dynamic with software-based solutions in the future is really key. The other question I have, and I have an opinion on this, production systems in the cloud. I mean, people say, oh yeah, we're going to move live production to the cloud. But for a lot of reasons, I'm not sure that makes entire sense. My opinion is perhaps you move key pieces to the cloud to integrate remote collaboration and things that make your production powerful. But at the end of the day, I'm not sure that a small data center tangent to your production core is not the way to go. What do you think? Do we move from a chunk of facility on the ground to a chunk of facility in the cloud? Or could we now truly distribute between cloud and ground and have best of breed in the right place?
I think that it's a transition. 20 years ago, we had the same transition with email servers. Everybody had their own email server in the company, on premises. At some point, we started using email servers on the cloud. It didn't call the cloud, it wasn't called the cloud, but it was external email servers. And some larger companies, which had lots of emails going inside the company, stayed with local email servers because of the bandwidth that it took to send emails to the guys that's sitting next to you through the cloud. Today, I don't think that anybody is even considering having a local email server. Because again, the bandwidth is a lot higher than what is required, even if you're sending huge files. So I think that in this case, it's going to be the same. You'll have cloud production systems for some unique cases where it really makes sense. And as time evolves, the technology will evolve, the bandwidth will be higher, and then at some point it will just it will not make sense to have a local system.
Right. That's true. It'll become ubiquitous someday. It's that gap in the middle and watching that evolution. And just an interesting side note: COVID has trained viewers to not expect top quality, and it's proven that it's the production content more than the production value that drives media. So it will be interesting to see how things roll out, especially in the live arena. We've used up our time, and there are still questions pending. All of our questions will be answered to the audience by email. I apologize, we've run out of time here. But I'd like to thank you for joining. I hope everybody's gotten something out of this. It's really tough to address a broad audience, but we thought it might be useful to just give a little tour of the universe here. Tomer, I thank you for your time. Your time is so valuable to us, and doing things like this take you away from the important engineering work, but maybe your brain enjoyed the rest. Thanks.
Thank you, Paul. It was a pleasure, like always.
You're a gracious man. I throw this stuff at you, and you do so well with it. Thank you. Like everybody to know that TAG, we can offer you a demo of the product we build in a very short period of time. If you would be interested, please contact us. You can just go to our website, tagvs.com. And right on there, you can get in touch with us, and we can arrange a demo. Because we're cloud resident, because we can be remotely operated, it's very, very simple, obviously, to put our product in front of your face without a FedEx label. Thank you so very much for joining. Your time is valuable, and we appreciate you sharing it with us, and look forward to the next time we see you all on here. Thank you, and have a great day, afternoon, or evening, wherever you are.